So now here we have so we have the pods, right? On top of the pods, what are the higher level of objects we have is deployments, then stateful sets, then daemon sets. Okay, so these are like what is a similar kind of name is these are called as pod controllers. Okay, so these are called as pod controllers. These are called. Okay, on top of the pod controllers, we have deployment, stateful sets, and daemon sets. We have. Okay, so what is the purpose of daemon set? What is the purpose of daemon set? Okay, so daemon set will make sure on each and every node one pod
At
need to
least
run.
one pod is running.
Okay, so we may have a log collection agent or monitoring agent, or we may have like a CSI kind of drivers, CNI kind of drivers. So those we are going to set up as the daemon sets we are going to set up. Okay, so then what exactly the deployments are doing? So deployments, in order to run the stateless applications, we are going to use the deployments. We have a declarative updates we are going to get in the template, and we can update rollbacks, or we can do the creation, deletion, auto scaling, all these kind of like activities we can do by using one single declarative update in the YAML file. If I go with the individual parts, what is the challenge here we are getting is, like here, what is the challenge we have is, like we need to create multiple parts. We need to create. So that's the challenging thing we have. Okay, so that's the reason we are not dealing with the individual parts. We are dealing with the pod controllers itself. For the stateless applications, we are going to use the deployments, and it provides a declarative update. So what exactly your understanding of declarative updates? What's your understanding of declarative updates? So with the declarative updates, what is that is, if you have the 100 replicas of the parts also, instead of creating 100 declarative kind of YAML scripts, we have one resource we are creating, and declaratively that itself is going to update even 100 parts also. Either at the creation level, updates, rollbacks, or deletion, all these we are dealing with the deployment itself. But what is the problem with the deployment is, we are not going to get unique and ordered kind of pods. If a pod is deleted, another pod will create. Say which resource is responsible for that? Which resource is responsible for that? So we have the replica set. When I create a deployment, replica set also is going to create, and the responsibility of the replica set is always that minimum number of replicas are running or not, it need to take care. The minimum number of replicas are running or not is going to be taken care by the replica sets. What is the purpose of the replica set? Okay, so then like what is the difference between deployments and replica set is, deployment is a higher level of object, whereas replica set is a lower level of object of that. But what is the problem is the replica set can take care that minimum number of parts are running or not. But what is the problem here we are getting is, like it won't take care of like updates or rollbacks. Only one time I want to create those resources, then directly I can create a replica set. Okay, and there is one more difference, like we have the replica set and replication controller we have. And with the replication controller and the replica set, which resource is new resource and which resource is old resource? Which resource is the old one and which resource is the new one? Replica set is the new resource. Okay, replication controller is The older version of the Kubernetes will have the older API server that can understand the replication controller. The newer replication controller is not understandable to the newer API server. That's the reason we can't use the replication controller as of now. We can use only the replica set, but directly we don't create the replica set also because we can't update a rollback. That's the reason we are going to use. That's the reason we are going to use the deployment itself. Okay, so replication controller is the legacy kind of component. That is also the purpose is same itself. Okay, what is the purpose is? That minimum number of parts are running or not, it's going to take care. But it's a equality based, that means exact matching of the labels it need to take care. But it more flexible. We'll discuss this. What is the meaning of equality based selectors and set based selectors? We need to remember these two terms while describing. But the newer API and the new resource is the replica set. Okay, and we don't directly create mostly will create indirectly itself through the deployment itself. Okay, so then now very, very important today we are going to discuss is like a Kubernetes service. So what exactly the Kubernetes service is? If you create a pod or maybe pod controllers like deployment or daemon set or stateful set, exposing of that pod is if that IP address is keep on changing. Okay, that IP address is keep on changing. That is the reason we're attaching a service to that to expose the pod. That IP address is like keep on changing and a very dynamic kind of environment. If I give the IP address after some time, if I give to the user, if that is keep on changing, what is the problem? If user tries after 10 minutes or 15 minutes, that IP address may be changes. We want a stable or static endpoint that is called as the service. Okay, so that means we are going to get a stable and consistent endpoint. My pod, my deployment may have 100 containers or 100 pods also. Those IPs maybe keep on changing, but I'm connecting to the service endpoint. What is the advantage is? What is the advantage is even if my pod IP is keep on changing, my service endpoint IP address, it won't change. So what is the advantage with that? What is the advantage with that? The users can access that. Users can access that 100 parts I have my deployment. Okay, say now try to understand here. I have one deployment. Okay, so that deployment having 100 replicas, that means 100 replicas will create 100 parts and we'll have the 100 IPs, and those IPs also dynamic kind of thing, and the parts would be keep on creating, keep on destroying, keep on auto scaling. Okay, so then that is very dynamic kind of networking environment we have. We want a stable endpoint, that is the service. That means the deployment IPs, all those we are abstracting to the end user. What we are giving to the end user? What we are giving to the end user? We are giving one endpoint using the service. It provides an abstraction of all those pod IPs, all those, and users are accessing it through the service itself. Those are going to access that. So that is the purpose we are going to use service. Okay, so we have different type of services we have in the Kubernetes. We'll discuss those type of services. We have very important, we need to know that services and
I
what are
mean,
the,
how many dynamic IPs will be there?
each pod will get one IP address.
Okay, I mean, it's just a joint. So, okay. So, I mean, the replicas is having 100 and pods also be having minimum of 100, right? It
Yes,
might
yes,
be max.
yes, yes.
Okay.
But
And
each pod will get one IP address mostly and one DNS name also.
okay. DNS. Okay. Yeah.
Okay. So then here what is going to happen is that IPs are very dynamic and I can't give to the user. After some time that pod also may be deleted. But even business wise, we don't have any impact because replicas it will make sure even with the pod deleted also a new pod is getting created. But it may get new IP address.
Yeah.
But
IP
user
address.
user don't know that IP address, right?
But DNS will be same, right? As yesterday mentioned, like DNS will be same, but IP will be
No,
changes,
no.
right?
DNS that is with the stateful set.
Oh yeah, stateful set. Okay. That I
But
mean,
here we have the IP addresses keep on changing, right?
okay. The DNS will be changes. Yeah.
So that is the reason whenever that even that pod also may be deleted, keep on it's deleting also. And we don't give those IP address how we know that each time we say suppose we were accessing a Hotstar kind of app also. Hotstar we know right, but we don't know what is the internal, what is the pod IPs we are getting. They may be running some millions of pods. Okay, the end user like abstraction we need to give for all those IPs for the application level. In the Kubernetes, we have for that service is that. Okay, so try to understand. A Kubernetes is a stable abstraction that exposes set of pods as a network service. That means we have 100 pods also. One endpoint we have is, what is our endpoint? Our endpoint is
Service to be
our
web
endpoint
service.
is the service IP address. Say suppose even I'll tell one example. Whenever we have Route 53 backend, you may have auto scaling. In the auto scaling, those IPs of the instances, that's I may give 4 to 400 also, but I don't access that's through. Like with my domain name only, I'm going to access right to the end users. What I'm giving, my domain name, I'm giving to the end users. The backend IPs maybe keep on fluctuating and IPs maybe keep on changing, deletion, creation. That's all auto scaling will take care. But we no need to worry about all those. Okay. So now here we have a load balancer also in the middle. But service will do even the abstraction of those IPs and even it will perform load balancing also it is going to perform. It is going to perform the load balancing also. That means if any of the pod is unhealthy, it would be removed also from that. Okay, so this kind of load balancing also it is doing. Okay, so what are the algorithms, all that also we'll discuss. Then coming to the services types, we have mostly 4 types of services we have. Okay, additionally, we can tell one more also we'll discuss. The first one, what you need to tell is cluster IP. The first type of service is the cluster IP we have, and NodePort is the second type. Then third type is load balancer. Okay, then we have external name or external IP we have, and fifth service type you can tell that as headless service. Okay, so 4 important we have, but additionally we can tell even the headless service also. What are those IP? What are those service names? First one is the cluster IP, and if I don't specify anything, by default I'm going to get cluster IP itself. If I don't specify anything, by default I'm getting cluster IP only I'm getting. Okay, so I'm getting by default cluster IP itself. Okay, so then we can attach to any of the cloud-based load balancers also. That means if I'm using AWS, then AWS network load balancer or application load balancer I can attach. Or if I'm using Azure, I can use Azure load balancer or Azure application gateway I can attach. Or GCP wise their own load balancers also we can attach. Okay, so what are all these service types we'll discuss. But generally, what are the types of services we have in Kubernetes? So we should tell we have 4 types of services. First one is cluster IP, second one is NodePort, third one is load balancer, fourth one is external name kind of thing. Okay. So then here one more we can tell, that is a headless service. So if I don't specify any of the type of the service, by default I'm getting cluster IP. So if I don't specify any type, by default I'm getting
Cluster IP.
cluster IP itself. Okay, so what are these service types we'll discuss. So what is the purpose of the cluster IP is, we can access the pod, but only within the Kubernetes only we can access. From outside world, it's not possible. From any of the node we can access, but that application is exposed only in the within the cluster itself is going to happen. From outside, we are not going to access that one. Okay, maybe for dev and QA environment, I don't want to expose outside also is fine. Then I'm going to use cluster IP kind of service. I'm going to use the cluster IP kind of service. In which use case you are going to use the cluster IP? In which use case you are going to use the cluster IP? I want to access only from the cluster itself. From outside world, it's not possible to access. Okay, so at that moment, I'm going to use the cluster IP I'm going to access. Okay, so but this is not for the production kind of workloads because we can't access from the outside. But even there is one
Outside.
more technique how we can expose it outside also we'll discuss. But as of now, by default, the service type is the cluster IP, and only within the cluster itself we can access those resources. Outside is not possible to expose. Okay, so then here we have internal purpose, like maybe say one front-end microservice, I have one pod that's backend, it want to communicate with the backend microservice. I don't want to expose outside. Then that internal communication can be done through cluster IPs. Okay, so but we have one more node port. So node port we can expose outside also, and one of the cheapest solution also to expose outside. Okay, so I'm talking about the cheapest solution is because if I have a load balancer, I need to create a cloud-based load balancer. Again, definitely cloud will charge the money for that. But without having any of the load balancer, we can expose outside also our Kubernetes like application by using the node port. By using the node port, we can expose outside also. Okay, so then all ports it won't expose. There are the range of the ports. Okay, so what are the range of the ports we can use is 30,000 to 32,767 are the range of ports we can use to expose. Means any of the node IP colon 30,000 to 32,767 one IP address we can use, and using those we can expose it to outside. We can expose it to outside. So that is the purpose we are going to use. That is the purpose we are going to use.
Headless service.
Yeah, headless. Sorry, it's a node port. Okay, so node port can expose outside also. Outside of the cluster also we can expose. Assume I have given one port number, any of the node IP colon that range is 30,000 to, like I given 30,007. That is in the range of 30,000 to 32,767 only, right? Okay, so within that range, what I can do? I can expose
A public outside.
outside also. So any of the node IP is fine, but from that port number we can expose.
So we need to externally. I mean, we need to provide, I mean, as you mentioned, it's a dynamic, right? So we need to give it like
No. From the
manual.
that IP is service we are giving, right? This is a service.
Okay.
The backend pod IPs maybe changes that service discovery is going to happen.
Oh, okay.
This is the service we are using.
Okay. Service numbers. So,
Not the pod IP, right?
okay.
So even in that node, even that pod is not there also, using this, it can be exposed. Okay. So on the static port on that node IP, colon, that port range, what is that we have given? Okay. So what is the purpose is maybe in the dev and QA environment itself, I want to expose outside the cluster. Okay. So not useful for, because the major challenge is we have the limited range of port numbers. What are those? 30,000 to 32,767, and internal there is no load balancing. Manual load balancing is going to be happen to that. Okay, and it exposes all the parts also security wise also. We have the challenges, and internal DNS also, it's not at all a production environment. Say in which use case you are going to use the NodePort. Say in my dev and QA environments, I want to expose my application outside. Then we are going to use NodePort. Okay. So then if I use the load balancer, what is going to happen is, so now here I need to specify, anyhow, this is the kind is a service and type is, what is the type I have specified here? What is the type I have specified? NodePort. If I don't specify the type is NodePort, what is going to happen? If I don't specify type is NodePort, what is going to happen?
It will be cluster IP by default.
Yeah, cluster IP it is going to become. Okay. And if I don't give that 30,036, what is going to happen?
It will automatically apply from
Yeah, within that range,
30,000.
one port would be assigned. If I don't give it, it is going to assign one port it is going to assign. Okay. So then if I use a load balancer, definitely I need a cloud is there like AKS, EKS in that. Okay. So then one load balancer I'm creating, normally when we create the load balancer, the backend we attach auto scaling groups or EC2 instances. But what is going to happen is to that load balancer, these parts are the targets. These parts are the targets, and to that parts we are exposing that load balancer, like to that parts it is going to redirect. But what is the problem? It's expensive kind of thing. For each microservice, we can't create one load balancer, right? That means if I have 20 microservices to expose that through load balancer, how many 20 load balancers we need to create? So it's a little expensive kind of thing. It's a little expensive kind of thing. Okay. So on top of this, we have one more solution, that is Ingress. That's we'll discuss in the next session. And the external name is, I have one domain name and I want to redirect to internally to my Kubernetes service. Outside, I have one domain name, but internally, I want to redirect to external DNS. Okay, so that's maybe like a Route 53, these kind of, but external name is one URL, but internally that need to be redirected to service. Okay, so then I'm going to use external name is the service type. With the external DNS name, domain name, I want to link. Okay, but in our scenario, we are going to use the Route 53 itself, and we'll expose that load balancer or maybe ingress kind of resource will expose. But this is also external name also we can attach. And additional type we can call, but technically we have 4 service types, but we have one more service also very, very important. Okay, and that is one of the prerequisite also for stateful set, that is called as headless service. Okay, so how we can declare as the headless service is, in the syntax we need to keep cluster IP is none. If I keep this syntax, okay, so that service is called as headless service. Okay, so now here try to understand. Here I specified not type is equal to cluster IP. I no need to specify, because if I don't specify also, it will become cluster IP also. But to make it headless service, what I'm keeping is, I'm keeping cluster IP is, I'm keeping cluster IP is
None.
none. If I keep this statement in my service file, that is going to become, that is going to become headless service. Headless service. Okay. So we'll discuss more on this. Why we need to discuss this headless service also. I'll explain. Someone asked one thing, right? Normally, the service discovery is going to happen based on the pod IP address. But with the stateful set, if the service discovery is going to happen based on the pod IP address, what is the problem to me? Even if the stateful set gives the same pod, what are the things I'm getting is, my pod identity is same, then pod DNS name is same. But which is not same? If the service discovery is going to happen based on the IP address, that IP address previous one maybe got changed. But for stateful set, what is the mandatory if that need to redirect to the same pod? Okay, say sticky kind of thing I want. Then what is the solution? Then what is the solution we have? Okay, so pod like service discovery need to happen not based on the pod IP address. Okay, then it need to happen based on, then it need to happen based on what? It need to happen based on the DNS name. Okay, but by default in the cluster IP, NodePort, all that, it is going to happen based on the pod IP address. But when I specify headless service, what is going to happen? If I specify the headless service, what is going to happen? If I specify the headless service, the pod discovery is going to happen based on the DNS based, not based on, not based on the
I
IP
mean,
address.
sorry, like you mentioned, there are two things. One is based on the IP
Yes,
based,
yes.
and one is based, right?
By default, that happens IP address based.
IP
But for
address
the
only.
stateful set, what is the problem is that IP got changed.
Yes.
That is the reason one of the prerequisite for stateful set is headless service. In the headless service, that discovery is going to happen based on
DNS.
DNS, not based on the
IP.
IP address. It's not going to happen based on the IP address. It is going to happen based on the DNS name. Are you able to understand that? So that is the reason for stateful set, if I use normal service, then that's not at all a stateful set. Because if any pod deleted, again IP address changes, service tries to redirect to that service, but that's not at all available. Okay, so now try to understand in the normal service discovery. In the normal service discovery.
And here I have a question, like you mentioned, there are 2 points. One is like normal deploy, right? So there also, if the pod is deleted, then new dynamic IP is created,
Yes,
new
yes,
DNS
but
is created.
that application, I don't want any, that's for stateless applications, right? No issue for me.
Yes, stateless places. There is stickless also you mentioned.
Yes, yes. That's the reason
Stickless is stickless has, I mean, again, it will create the same same pod with the same IP as well.
I'm sorry, I didn't get you.
No. Yesterday you mentioned that like when we deleted stickless or something, right? When we deleted the pod,
Stateful set,
the
that
pod.
is.
Sorry.
Stateful set.
Oh, that is all stateful. But you mentioned yesterday, if you delete the same pod, then again it will create the same DNS and
That
same
itself is
IP.
stateful set. So now here we have deployment.
Stateful, stateless. Okay.
Deployment is purely for stateless applications.
Stateless. Okay.
Okay. Then we have stateful set.
Full set. A little confused. Okay. Yeah.
Then we have daemon set. Okay.
Okay. Yeah.
So now for the stateful set, headless service is the prerequisite.
Okay, which is required DNS. Okay.
Yes, yes. Because otherwise that feature itself we don't get it. Okay. So now, like the service discovery is going to happen based on the DNS name it is going to happen. Now try to understand here. We have pods. These pods are getting exposed even to the service. And even we have one more resource. The services also can be exposed and load balanced to the outside the cluster by using the ingress resource. By using the ingress resource, even we can expose. Okay, so that services also. Okay, and finally, this ingress will create one load balancer. Okay, so tomorrow we'll discuss more on the ingress. That load balancer I'm going to attach to Route 53. Then can you tell me in the reverse order how the user will access? User will click that, say suppose cloudsoft.com, the domain name. It comes to Route 53 DNS. Then from there to load balancer, then ingress, then
Import.
service to
Pods.
finally my application has been running in the
Pods
itself. So maybe you are watching IPL, even that Hotstar, that streaming also is happening in the pod itself. We are all accessing Hotstar, right? App. That Hotstar also will, like that application is running in the pods. That video streaming of that IPL streaming is happening on the pods itself. Do you get that?
Yes, I got it here.
That's all. Like we have Azure DNS and the load balancer, ingress, service, then finally that pods. And that pods are keep on auto scaling. Because we can see dynamic loads, right? In the IPL, sometimes we may see 40 crores, sometimes we may see only 3 crores. If all they maintain the same number of nodes, they will face a huge loss for that maintenance. Okay, so dynamically they can scale up or scale down also. Okay, so that is the reason normal EC2 instances or virtual machines are not possible to manage. And what is the problem with the EC2 instance is that scaling will take minimum 5 minutes to scale up. But whereas parts, it would be in the seconds itself. In the parts, that's going to happen within the seconds itself is going to happen. That is the main advantage of using that is the main advantage of using for the microservices we are going to use for our applications. Okay, so that's the ingress with the pods itself are exposing through a service, and multiple group of services can be exposed using ingress kind of resource. And ingress, if I want to work on the Kubernetes, we require ingress controller resource. But by default, we are not getting ingress controller on our. By default, we are not getting ingress controller on your kube controller kind of resource. Hence, we need to create again our own explicit ingress controller also will use. For AWS EKS, AWS is providing ingress controllers. For Kubernetes, there are a lot of companies are contributing also for the ingress. That ingress part we'll discuss. Then tomorrow you need to come with one solution. What is that is for the pod, okay, for the namespace, for deployment, for the daemon set, for stateful set, replica set, replication controller, next services. Almost how many services? For 5 services. Okay, so you need to come with kubectl commands and those YAML files also. Okay, so you take for Tomcat application something. Okay, so these all the YAML files we need to know. Okay, and services also you need to create, and commands also through kubectl also we can create, or through YAML also. In the real time we are going to use. In the real time we are going to use YAML scripts itself will use, but sometimes kubectl commands also we need to discuss. Okay, so this will come in the tomorrow session, and ingress also will discuss. Okay.
Okay, sir. Yeah, thank you.